Hello, my name is Ardi and we are going to solve problem 7.35 from Sadiku book. So the question is find the solution to the following differential equation. We are given two differential equation A and B. Okay, let's start from problem A first. I will rewrite the problem first. So we will have dv over dt plus 2v is equal to 0. And then V0 is equal to minus 1 volt. Minus 1. Okay, I don't write the unit here first. Okay. I think we can use separable differential equation. So the goal is to separate the variables. One variables on the left hand side and the other on the right hand side. And our target is to separate the V and the t. So I want all the v on the left hand side and all the t on the right hand side. Okay, I think I can move this plus 2v to the right hand side here. So we will have dv over dt is equal to minus 2v. Okay, but then we can cross multiply or we can swap this v with dt. So we will have dv over v, and that will equal to minus 2 dt. And this is good. Why? Because we can integrate both sides, right? So we can integrate both sides here. And this is actually 1 over v dv integrated, right? And we all know that it is the natural log. So we will have ln v here. And then on the other side, we will have minus 2t. And remember that we have actually plus constant on the left hand side and plus constant on the right hand side. But then we can merge them into one constant on the right hand side, right? So I will have some constant here. But we want to find out v, so we take the exponential of both sides. So e to the ln v, that will be v. And then on the right hand side, we will have e to the minus 2t plus C1. Okay, and therefore we will have v. We can separate this, right? So I will have e to the C1 and then e to the minus 2t. Or we can write this part as a constant. So I will have a and then e to the minus 2t. So we'll have v t is equal to this one here. However, we have not done here. We still need to find out what a is. Where do a came from? We can find out a from this initial condition. So we know that v0 is equal to minus 1. v0 means that vt, the t, is replaced by 0, right? So v0, that will be a e to the minus 2 multiplied by 0 because our t is replaced by 0. And then this will equal to minus 1. Minus 2 times 0 is just 0. So we will have a e to the 0 on the left hand side. So this will equal to minus 1. And then e to the 0 is 1. Yeah, anything power of 0 will be 1 except for 0. And so we will have a multiplied by 1. And that will equal to minus 1. A multiplied by 1 is just minus 1. So I will have a is equal to minus 1. Okay, and now we can substitute this a into this equation here. So we will have vt is equal to minus 1. Or I just write it minus e to the minus 2t. And that is the answer for this problem, question A. Okay, now let's move on to question B, but first I want to clean up the slide. Okay, now move on to question B. Okay, let's rewrite the question first. So we will have the question B, we will have 2 di over dt minus 3i is equal to 0, and then I0 is equal to 2. Okay, now again we can do separation of variables. We want all the variables to be on one side, so I want the I all in the left hand side and all the t on the right hand side. Okay, let's do exactly that. So I'll have 2 di over dt, and that will equal to 3I, right? And we can divide both sides by 2, so we will have di over dt is equal to 1.5I. Okay, now we can swap this I and dt, so we will have di over I, and that will equal to 1.5 dt. And this is good because we have all the I on the left hand side and all the t on the right hand side. So we can integrate both sides here. And remember, this is 1 over I di integrated, and we will get the natural log of I plus some constant actually, but we can move it onto the right hand side, right? And then we will have 1.5t, so plus some constant. So the constant is actually on the both sides, but I merged them into this single constant. But we are asked to find out I, so we take the exponential of this equation here. So we will have I, and on the right hand side I will have e to the 1.5t plus c1. Okay, we can rewrite it as I is equal to e to the c1 multiplied by I to e to the 1.5t, right? But this is a constant, so I can rename the constant as a, right? So I will have a e to the 1.5t. Okay, so our final task is now to find out this a here, and we can do it by using this initial condition. So I0 is equal to 2, and then we will have on the left hand side a e to the 1.5 multiplied by t is equal to 0, so we'll have it like this, and then that will equal to 2, and then we will have a e to the 0 is equal to 2, e to the 0 is just 1, so a multiplied by 1 is equal to 2. 1 is the identity element, so I will have a is equal to 2. And we can substitute this a into this function here, so we will have it is equal to 2 e to the 1.5t. And I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.